welcome to my talk about Spryker. So I'm very happy to have you here. So conference is almost over, and well, I still see at least 50 people here. So thank you very much for coming to the talk. I would like to introduce myself first. So I'm Fabian. I'm the CTO of Spryker Systems. Please feel free to follow me on Twitter or tweet about this talk if you like to. And you can also read my articles on my blog here, Spryker Tech Blog. So now, from now, I would like to talk about Spryker. Spryker is an e-commerce framework. So, and we started Spryker 2 years ago. And before I explain what Spryker is, I would like to explain why we created it. So you probably know Magento, you probably know Oxid, you probably know Shopware or other e-commerce frameworks, other e-commerce systems. And the question is, why do we need another e-commerce framework? So when we started, we looked at these graphs here. So we see there are some 100 of shop systems in the market, open source or enterprise shop systems. And but still, a lot of companies run on their own self-implemented software. So there are a lot of shop software that you can just use, but still people decide to build their own thing. So why? Well, that's because the approach of the existing software. So there is standardized shop software that has a lot of features. So probably when you know Magento, it comes with thousands of features out of the box, and you can configure them. And there are extension points, there are hook points for API calls, for plugins, and so on. And that's totally fine for the long tail of merchants. So probably all small merchants will be very happy with this kind of software. But it does not fit for ambitious projects. So if you have a project, e-commerce project, that is not standardized, then a standardized software will not fit what you need. So if you work in e-commerce, you probably know in the beginning it's nice, you take the Magento or Shopware, Oxid, and then you start to build feature on feature on feature, and then you start to build a big bunch of code, and then the productivity goes down. So, and this is our approach. We say, instead of an out-of-the-box solution, we think that ambitious projects, they need a framework that optimizes the productivity of the developer. So it doesn't matter how many features you have in the beginning, but what matters is how fast you can build new features into your shop, how quickly you can adapt your business model to the market needs. And so that's basically our idea. We have a framework that optimizes the productivity of the IT team. And as you can imagine, productivity is a quite soft requirement. So how can you build something that optimizes the productivity? And this is what we think makes developers more productive. So we think a system that ships with clean code, that fits to the solid principles that you probably all know about, which has a consistent software design, so something which is a solution is repeated over the whole system, the same patterns, the same principles. If you know one part, you probably can easily learn the other part of the system. We think a strict modularization is super important. So it's not about one big bunch of code. It should be a system that is clearly divided into packages. Then the feature set. We're talking about e-commerce here. So there should be features. There should be a cart. There should be a checkout. There should be some other features. But we need features that are generic. So not something that you can take out of the box, you can configure. We need features that allow you to build what you want very easily. So we have state machines in the system. I will show you later state machines. And this is a very good example about a very generic feature. We also think that high performance and scalability is super important. Not everybody has a shop which has extremely high traffic, but when your IT team needs to fight with the application the whole time, then it's wasting the time. So every minute that you need to spend into full-page caches and database replication is wasted because you will not sell more products. So that's our approach. We think if system is fast, out of the box, and scalable, the team doesn't need to care about. And then we need deterministic behavior, so system exactly the same for each URL. Then we need tested and measured code out of the box, and then on top of all these good practices, we want to avoid bad practices. So we do not want to have any full-page caching. We do not want to have entity attribute value database schemas. We do not want event dispatcher, ASP.oriented programming, and so on. So all of these things you will probably also know from other talks. These are very cool things from the developer's point of view, but they all have negative trade-offs. So, and I think in a big system, we should avoid them. So that's basically what we defined as a software that increases developers' productivity. And now I would like to show you the result. So Spryker. That's the so-called bird's eye view. So in German, it's Vogelperspektive. You can see the application is divided into two applications. The system is divided. Here we have Eve, shop front end, and set the shop back end. And that's one of the initial ideas that we had. So we say, okay, every shop has a customer-facing front end. And here you want to, that should be lightweight. You want to change it very, very quickly. It should be scalable. It should be very fast. So it should be a very lightweight application. And then you have a backend application. You have a backend where you have the administration UI. You have your business logic. You want to persist your data, and you want to connect to ERP systems, payment systems, logistic providers, and so on. So you have something heavyweight and something lightweight. And it absolutely makes sense to split it into two applications. So the front end is called Eve, the backend is called Set. So when you go to any Spryker shop, you will only see the Eve part as a user. And the Eve part is an application that should be very fast and scalable. And when you look at this diagram, you can see why it's fast and scalable. The Eve part does not contain the business logic, so we just get rid of a lot of PHP code that makes it faster. And the relational database here is not directly connected to the front end. So the only way to save data is to send a call, a little web service call here from Eve to Set, and to put the data here. To show the data in the shop front end, the data is loaded from this key value storage. So you can imagine when you go to a product detail page, you need to show a lot of information. Product description, images, prices, category, stock information. So that results in a very heavy database query, or maybe several database queries. So, and instead of the database queries, we have the data here in the key value storage prepared in an array. So it just needs to look up into the Redis to get all the data prepared. It's not a cache, because the data is not, there's never a miss. So the idea is, whenever something changes here, then there's a cron job that pushes the data to the Redis. So this is a little bit like a database slave with prepared data. So this one is extremely fast, because the data is prepared and it's already aggregated, and it scales horizontally very easily. We have a second Redis for the sessions. Same problem, we want to read and write sessions very, very quickly. And of course, in a scaled system, when you have several servers, we need to replicate the session data. And Redis is doing this really, really good here. And then we have the search engine for the facet filters, for the full text search. And it's basically the same idea than the Redis. So the data comes from here. So whenever something changes here, it's written from the set application to the Elasticsearch. and here it's queried. So this way, we have an application that has two very, very fast data sources, and a third data source for the sessions. It's lightweight, so it's very easy to change, and the whole business logic goes here. So this is our application that has an SQL database. It should be Postgres or MySQL. We have a queue here, and here you can see it's connected to several external providers. So this one here is a, well, from the developer's point of view, it's a logging system. So the system creates events all the time, and all the events are written and can be retrieved for business intelligence analyzers. So when you work with Spryker, basically you have to have in mind all the time this picture, because you need to know, okay, am I changing if or z, or what am I doing? And well, the result here is quite good, I think. We did a load test on Heroku, and we reached, this is our execution time on a big Heroku instance with PHP 7, and then the execution time goes up to this here under pressure. So when you put some 10,000 requests per minute, execution times go up. So that's the result of a PHP application that is lightweight and has no SQL bottleneck to read from. In general, the code, when you get Spryker, you get basically two code bases. We have the core bundles on our side, with a quite good quality in the code, and you also get a project boilerplate. So this is a scrutinizer scoring. It's scoring from 0 to 10. So you can see the code base is really good when you measure it, and that's the idea. So you take the boilerplate for your project. We recommend to use scrutinizer in your project, and then the code quality in your project will be, you can measure it, and it hopefully will not go down. So this way, the idea is we inherit the code quality from our system to the projects. So if you build a project with Spryker and you get an 8 here, you did something seriously wrong. In general, Spryker is a lot about these three books here. So these two books here is about solid principles and packaging principles. That's the original book that every developer should know, I hope, from Uncle Bob. And that's a newer book from Matthias Novak about PHP and solid principles. I highly recommend to read that book, by the way. And we're also very into clean code. So clean code says, hey, you should have short methods which are doing one thing. It's about naming conventions. It's about how to structure code. So this is one of the main ideas of Spryker, that we ship it with all this stuff, and then in the projects, developers should continue like this. So a Spryker project should have a very high code quality. Okay, now I'll tell you a little bit more about the software design. I think I already explained this. So we have two applications, if and set, with the two quick data sources and the SQL database. And then when we started when we looked into the application, we needed to decide which way to go. So probably today you heard a lot about microservices, and with Spryker, the idea is to build an application that fits to small teams, but also works well with very big teams. So with Spryker, you can work with 3 developers, but also with 50 developers. And here we need to decide how to structure the application. On the one side, Spryker should be a normal PHP application. So a normal PHP application that you can install on your laptop, that you can debug, and that you can simply deploy. On the other side, we also want to get the benefits of the service approach. So we want to have something that allows to work with very big teams, and where you can update or replace single parts of the application. So what we not want is the bad trade-offs of service approach. We do not want a technology zoo. We do not want that the projects using Java and PHP and Python and Ruby and then go into chaos. We do not want to have the overhead of a distributed system, and also we do not want to have the complexity of asynchronous communication. And we do not want that our customers have to manage several databases and take care for replication and redundancy. So that was our initial thinking. So then we started to say, okay, based on this, our application should be a single application, or the bad word is monolith. So we think a monolith is better for this kind of software, but it should be a modular application. So we divided the application into functional units, and these units follow the, well, they have a single responsibility and well-defined relationships, and they follow the packaging principles. So the idea is to have not only directories, the idea is to have something that acts like a service and has very, very clear boundaries and dependencies, but inside of one big application. So this way, we want to unlock most of the benefits of the service approach, but without HTTP calls between the objects, so without the network overhead. So these bundles, when you look inside, you will see the inner architecture. We have 4 layers in the application: presentation layer, communication layer, business layer, persistence layer. So and the idea is that every class that you build has a very, very clear place. So every class, it should be very clear which bundle you will put it, and then which layer. If this is unclear, it will result in a mess. So I think with this horizontal and vertical structuring of the application, it should be very clear where to put what. But as I said, this bundle is it should not only be a directory where you put everything that has to do with card. We need a little bit more here to make this a real package, a real bundle. So, and very important, in PHP, you have, when you think about method visibility, you have private, protected, public. But what's missing in PHP is the package visibility. So in a system, when you have classes with public methods, then it's often not clear who can use these methods. So with Spryker, we say, we have a bundle which has code. It can have hundreds of classes. But from the outside, you only see one class, and this one class is a facade. So this is the implementation of a facade pattern. You probably know from the Gang of 4. It's a traditional design pattern. It's quite famous, but not often used. So this is a so-called card facade. You can imagine like in a web service that would be the API. So you have one class that defines all the methods that you can use, but it completely hides the inner implementation. So you can see the card facade has add and remove methods, and it just delegates. Delegation happens here, so it uses a factory to create a model and just delegates. So it looks very, very simple, but it's a very, very powerful pattern, and it's super important that in the whole code base, nobody goes around the facade. So direct calls are not allowed. The only way to come to these classes here is to go through the facade, and there's only one facade. And this way, we can say all classes here, which have public methods, have a package visibility. So you can only use them inside of the card bundle, but not from the outside. So in general, I highly recommend to use facade pattern to structure bundles. So here we have 2 bundles that communicate with each other. We have the card bundle and we have the calculation bundle, so which is responsible for the calculation of cards and checkouts. And we're using a class called Dependency Provider, which connecting this one. So here you can see the card asks for the facade of the calculation bundle. So the rest here is just for performance. We have a closure here because we want lazy loading. This is a pimple container. It's also for lazy loading. And this is a service locator, which is used so you can globally exchange classes. But the main idea is that each bundle defines which other bundles are required. It's a little bit different than what you have in like Symfony framework, where everything, where you just make more or less anonymous calls on the DI system, because this is a quite this is a very explicit coupling here of bundle-to-bundle dependencies. Here, I think so a summary here. So we have a bundle is a functional unit. So, and the definition of a functional unit is often not very clear. So when you build a system like this, you will have a lot of discussion. What is a bundle? Should we put it in? Should we create a new one? So overall, we have 100 bundles here like this. And super important, they must be loose coupled. So you have only these dependencies which are needed, nothing else. And they are co-rent. That means everything which is inside of the bundle belongs there. So everything is in the inside uses each other. There's no class in a bundle which is not used by any other class. Both is measurable, by the way. And explicit dependencies. So our dependency provider is the only place where we say, okay, we need this and this and this other bundle. They follow the packaging principles. If you don't know them, that's not a problem. These are like the solid principles for packages. So they're a little bit heavier to understand, and I highly recommend to learn them. Yeah, and the main idea here is that the code keeps structured. So when you have a very big system, you will have a very, very high number of bundles. But like in a service infrastructure, it's very clear where the code belongs. And even if a lot of people are working the same application, they do not interfere with each other. This way, we can also have a new way of releasing or shipping our code to our customers. Each bundle has its own version number, and we're using Composer. So if you like to, you can install our demo shop, and you can look into the Composer.json, and you will see something like this here. So you have a long list of dependencies. And we did this because we want to solve a conceptual problem that we have. So we have an e-commerce framework where you build your stuff on top. So when you build something on top, you will, with a very high chance, lose compatibility in some regions of your application. So maybe for a specific business model, you have a completely different product catalog. So you change the product catalog completely. So it's not compatible anymore with Spryker. And the idea is you will fix the version number for the Spryker catalog bundle, or you completely remove it from your list, but you can still get updates in other bundles. So it can happen that you need to log into several bundles, but you can still take, for example, the new update of the CMS or the new update of the discount bundle. So it will not block you from taking new updates. You can also remove bundles if you don't need them. You can add optional bundles. So this way, it makes it very flexible for our customers to use what they want, to update what they want, or just to remove. For us, as core development team, that's a big challenge, and it doesn't really matter for our customers how we solve it, but I will tell you, our core development happens in one big repository, and when we merge to the master, then we have a server running, which will get these updates. We have a git subtree split running there, a little shell script, which using the git subtree split function, and then it will pass all the commits from our big repository, and will map it to these bundle repositories, and then will forward the change sets to these repositories here. So then we have one big repository, and our customers have these 100 small repositories. If you do something like this here without preparation, then the Composer update will take 1 or 2 hours on your laptop. So this we solved with a pre-caching of the dependency combinations here. The software that we use is called Torrent Proxy. It's a commercial version of Satis. So it's more or less the same software that's used by Packagist. We acquired a license, and it's mirroring our GitHub. And when you run Composer install or update, it will take only some seconds, and you get all of this. So, but you can imagine the amount of combinations here that are possible, and the invalid combinations it's a very huge number. We didn't even try to do this without Torrent Proxy. It will result in hours and hours of waiting. Okay, now I would like to show you the code of Spryker. So very important is in general how you build your how you connect classes to each other. So in general, we say we only want to have a dependency injection everywhere. So we never want to allow that somebody writes new some model. That's not allowed. It's not allowed. You always inject dependencies through the constructor. You always use interface there. So it's a very clear coupling. So it doesn't take more time to program this way, but it makes it testable and decoupled, and in general, it's a very good approach to do it like this. And to do a dependency injection, you need some place in the system where you connect your classes. And here, we decided to do it the simplest possible way. So we have each bundle has a factory. The factory creates a new class here. You have a method create translation manager. It creates a new translation manager, and it just injects all the dependencies. So behind each of these methods, you find a new method like this, where you inject again the dependencies. So the complete injection is explicit here in one class. It's IDE friendly, and yeah, it doesn't need any explanation. So it's probably the simplest way to do dependency injection. And you don't need any framework. So there's no, so every framework like Symfony 10 framework, they bring a lot of DI, container, background magic, but it's not really needed. Of course, it's not that powerful like a Symfony DI system, but we never needed it. This is totally enough. And it's PHP, so you can change it very easily. And another very important concept in Spryker is plugins. So we follow the solid principles. That includes the open-close principle. That means the code can be modified from the outside, can be extended from the outside without you need to modify the code itself. So, and this is something that we really take serious. And to do that, to realize it, we're using plugins. So this here is the calculation bundle. It's a card calculation, and card calculation is a quite complicated thing. You need to sum up the items. You need to add the product options. You have discounts. You have taxes. You need to calculate several totals, and we could easily put the whole calculation in one big method like this, where everything happens. And then if you want to change it, you have to overwrite the whole method. So that's probably not the best idea. That's why we're using a plugin stack here. So this is an array of plugins. And each plugin gets our quote object and is using the existing information to calculate new information and to add this on the quote. So the mechanism is quite easy to understand. And the cool thing is that the projects can take this calculator stack and change it. So, for example, you have an e-commerce shop where you make global shipments. So, and then you ship to like Egypt. And Egypt, you have a special tax. So, and only in this case, you want to apply a special tax. This is not something that Spryker can do out of the box. It's an edge case. But then you would go here. You would probably take the tax plugin or just put a new plugin there. And this way, you can hook into the application and change the behavior. And the only class that you need to change is this one here. And this class here can be extended in the project. It's expected that you extend the class. So, and we have this plugin stuff everywhere in the system. So like everything can be extended like this with plugins. And the plugin is it's a realization of the inversion of control principle, by the way. So you also change the direction of the calls. So in this way, it's not the calculator bundle which is calling the other bundles. This way, we allow the other bundles to call the calculation bundles. So it's an inversion. So we have the plugins everywhere, but still we expect that projects need to override classes from the core. So there is always cases where you have to replace something in any class and where it's not expected. And with Spryker, we say inheritance is okay, we can do this. You will probably get trouble with the next update, but that's fair enough. But we also highly recommend to do composition. So that's a project class here, which gets the which is implementing the same interface than the class from the core, and you inject the core class to the constructor, and then you delegate all public methods to the core class. So this way you can wrap the whole core code, and you do it in a very clear way. So it's not about some magic. It's not about hooking into the method somehow with aspect-oriented programming or with some XML magic. It's a very traditional way of extending classes without inheritance. Another important concept in Spryker is the way we handle data objects. So what we not want is that people use arrays everywhere. So otherwise you will have arrays where you have like a first name with small characters, you have a first name with first minus name, maybe with big N. So to avoid this, and to give very clear structures, we're using data transfer objects. Yeah, I think it doesn't need a lot of explanation. We have these objects here. You have a customer transfer. You can have set, and then you can get. That's it. So these objects are very powerful. We define them in XML. We can also give the type here, and we use this also. We can also merge these objects to each other. And now I would like to tell you the one of the features, of the main features of Spryker. I think I will tell you a bit more than we have on the slide. It's we think a shop system which should orchestrate the order process. So I think one of the reasons why productivity is lost in a lot of companies is because they're using the shop only as a big checkout, and then they send the orders to an ERP system. And then the ERP system needs to handle the payment. But you also have the payment in the shop, so you need to have the payment twice. And then the shop wants to show the order status in the customer account. Then the ERP system needs to send back the customer status to the shop. And then you want to cancel the order from the shop. Then you need to send back a message from the shop to the ERP. So if you build a system like this, you will have a lot of interaction between the ERP and the shop system, and that makes you extremely inflexible. So you are for every change that happens in the order process, you have to talk to the ERP team. Maybe it's not possible. It will restrict your productivity enormously. That's why we say the order handling should be part of the shop system. So the shop is responsible for orchestrating the whole order process, to having the complete communication to payment providers, to send all transaction emails, to talk to the fraud protection API, to take care for refund, return, cancellation processes, to have different payment methods. And if you want to, you can have everything different in different countries. So I highly recommend to do it like this, to have the complete order process in the shop, and the ERP system will only take care for the fulfillment part, so pick, pack, shipped. That's everything that the ERP system should do. And to do this, Spryker ships with state machines. So the idea is that the whole process of the order is described in XML. The idea is you build the whole process. You start to draw the whole process on the whiteboard. So you think about, okay, I have my order, I have my item. At the beginning, it's new. Then I ask the payment provider. Then the payment provider, I need to wait 10 minutes. Then I get a message back. Then I will send the email. Then I will ship it. Then I have to wait until I get the message. Oh, maybe I get a return. Maybe I get a cancellation. You draw the whole process as a state machine on the whiteboard. Then you bring it into Spryker as XML, like this here. It's very easy to read and very easy to write. And you can visualize this like this. This is a graphic visualization of the state machine. And then Spryker allows you to not only model and visualize, it also allows you to execute the state machine. So you have these states here, which are states on the order item. You can call events like authorize. This here is a PHP class. So when the item goes from here to here, it will call this PHP class to do the authorize call to payment provider. We also have a PHP class here to check the result of the payment provider. So this way, you start to structure your process state machine, and then you can build, you have building blocks. You have your commands that interact with the payment provider, that send emails, that send items to the fulfillment. You can build this test-driven, so you can build them isolated with tests, and then you can just put them into the XML, like this here. Here's a command authorize, and then you can execute the process. So this is a tool which is an example how Spryker works. So what you get is the infrastructure to build state machines and to run them for orders. Out of the box, it will do nothing for you. But in 2 or 3, 4 weeks, you can build a complete process or several processes, and you can automate orders completely. So if you have a shop which has like 10,000 orders a day, you cannot do it manually. So this way, you have a tool that allows you model, visualize, automate it, and it also gives this diagram gives you a possibility to talk to different departments of your company. So you have the state machine, and now you can talk to the operation team, to the customer service team. And a lot of companies use this. That was the first time ever that they are aware of their process and they can talk to each other. So it's a very, very powerful tool. And it needs a little bit of training to concept these state machines. I mean, to learn the XML, it takes you 10 minutes. That's something that everybody can do. But to learn how to build a big state machine will take you probably 1 or 2 weeks. And but I highly recommend to do that. Okay, you can, if you like to try it, you can just run Spryker. It should, it works on most laptops. At Spryker, we're all using Macs, so our virtual machine can be installed on a Mac without any problems. On Linux, it's doable. On Windows, it depends on the Windows version. You may get problems, but please ask us if you have a problem here. So the installation takes 20 to 30 minutes, and then you get all of this onto your laptop. We have a demo shop that looks like this, and you can make orders. You can go to the customer account. You can use the state machine. You can also look into our code. The GitHub repositories are public. In general, Spryker is not open source. It's open code. That means you can look at the code. You can use it locally. You can try it. But when your company wants to use it for their production environment, they have to pay for it. And to give you a reason to run Spryker, to have a look at it, we have a lottery. There are these little papers here on the chairs, and we created a little game. So you should install Spryker. You can switch to a branch, and then we have a little tutorial there, and you make a call, a web service call to a backend application, and you can win a €500 Amazon voucher. So if you'd like to try it. Yeah, I want to give you some more links here. We have a documentation. It's hosted on GitHub pages. We have a forum, so if you get any problems with install the virtual machine, please come to our forum, talk with us. And we also have a tech blog. I recommend to look in the tech blog. There's a nice article about our load test, so you can see what we did there at Heroku, how that works, how it was configured, how it's installed, and how far we can go. And you can also look into Scrutinizer to basically to see the measurement of the code. Sure. The code is, as I said, it's good, but of course there are also bad parts. So if you like to, you can also see the bad parts. This Eve application has an MIT license, so if you want to, you can fix the bad parts. That's it for now. So I think 4 minutes to go for questions. I will stay here. You can also come over if you like to. Nobody? It's late. Thank you very much. Have a nice evening.